calculators for these problems. Okay, you're going to use logs to solve exponent problems. So these problems look exactly like the exponent problems you looked at last chapter, except now you're going to use logs to solve them. Okay, so the weight of a bacteria in a culture after T hours is given by 20 times 2 to the 0.15 T grams. Find using logarithms the time for the weight of the culture to reach 30 grams, for example. Okay, so that's basically saying 30 grams is equal to 20 times 2 to the 0.15 T. Okay, and this is the times. Okay, so how do we solve that using logs? Well, this is similar to what we were doing a couple problem sets ago. We want to isolate the t, okay? And when we do that, we'll see that eventually you have to use a log. First thing we're going to do is divide both sides by 20, right? And then you end up with 3 halves is equal to 2 to the 0.15 t. And then we need to get the t down as a regular number, not an exponent. So to do that, we need to take the log of both sides. What kind of log? It doesn't really matter. Let's take the natural log. Natural log of 2.15t. And then we could just change that to 0.15t times natural log of 2 is equal to the natural log of 1.5. And then we'll divide both sides by natural log of 2. And then we'll get 0.15t is equal to natural log of 1.5. That does not look like 1.5. Okay, divided by natural log of 2. And then, so t is still not by itself because we need to divide both sides by 1.5 or 0.15. So now we have natural log of 1.5 divided by natural log of 2 divided by 0.15. And that'll give us t for 30 grams. 100 grams is going to be similar. We'll have 100, we'll start with 100 equals 20 times 2 to the 0.15 t. We're going to divide both sides by 20. We'll get 5 on the left side. We'll get 2 to the 0.15 t on the right. And then we need to take the log of both sides. Natural log of 5 is equal to the natural log of 2 to the 1.15 t. This is the same as 0.15 t times natural log of 2. Can divide both sides by natural log of 2. Then we end up with 0.15 t is equal to natural log of 5 divided by natural log of 2. Divide by both sides by 0.15. And we end up with t is equal to natural log of 5 divided by natural log of 2 divided by 0.15. So those are the two answers. If you divide that on your calculator, you'll get the numbers. Okay? So we used logarithms to figure that out instead of using graphing or the table on the calculator. So number 3. A biologist is modeling an infestation of fire ants. He determines that the area affected by the ants is given by area equals 2,000 e to the 0.57 n, where n is the number of weeks after the initial observation. Okay. Draw an accurate graph of a to the n against n, so n, a. Use your graph to estimate the time taken for the invested area to reach 10,000 hectares. Check your answer to be using logs and suitable technology. Okay, so let's see. So the first value of a is going to be when n is 0, which would be 2,000 e to the 0, which is 1, so it's going to be just 2,000. So the initial value of a is going to be 2,000. So let's say this is 0, this would be 2,000. So the initial value is going to be right there. And then like what if n was 1? So when n is 1, area is equal to 2000 times e to the 0.57 times 1. So e to the 0.57, let's see, e to the 0.57 is equal to 1.768. If I multiply that times 2000, I get 3536, which would be about there. Okay. All right. And then what would be the value for 2? That would be e times 2 times 0.57, 3.16. And then I would multiply that times 2000, the initial value. And I got 6253. So 2, the value would be 1, 2, 3, 4, 5, 6. There. Okay. So that's kind of what the graph looks like. Use your graph to estimate the time it takes to reach 10,000 hectares. So let's see, where is 10,000? 10,000 would be 4,000, 6,000, 8,000, 10,000. It would be about here. So it looks like it would take about 3 hours. 3 weeks, right? So I would say about 3 weeks. Check your answer to be using logs or suitable technology. So first we'll use technology. And the way I would do it is I would just graph this equation. Look at the table. So second, e to the x, 0.57, x, 57, not 75. X. Second table. So at 0, it has the value of 2,000, just like our graph says. And yeah, it looks like it should hit 10,000 right before 3, not at 3. It would be a little bit less than 3, but that looks pretty close. And then if we were going to use logs, we would take the natural log of both sides. Well, actually, first let's do this. We're gonna write out, okay, how long does it take to reach an area of 10,000? So I'd have 10,000 equals 2,000 e to the 0.57, and we don't know what n is yet. So then we divide both sides by 2,000 because we want to isolate the n. Get 5 equals e to the 0.57 n. Could take the natural log of both sides so that we can get the n in the as a regular number, not the exponent. So we have natural log of 5 is equal to, and these cancel each other out, so you get 0.57 n. Divide both sides by 0.57, and then we end up with n equals natural log of 5 divided by 0.57. And then if we check that, we'll get natural log of 5 divided by 0.57, 2.82. So you can see that's pretty close to 3. We had guessed 3, right? Let's move down here. Number 5. Tabo has $10,000 to invest in an account that pays 4.8% compounded annually. How long will it take for his investment to grow to $15,000? Okay, so for this one, we're going to use multiplication factor, which is 4.8%, which is 0.048, plus 100%, which is plus 1. So the multiplication factor is going to be 1.048. Okay, and then so we're going to say it's going to be $10,000 times 1.048 per year. Okay, and that's going to give us the investment amount, okay, which we'll call, let's say it's I. So when is it going to grow to 15,000? How many years does it take? Well, we're going to solve this with logs. So we'll take the natural log of both sides. Doesn't really need to be natural log, it could be regular log. Before we start that, let's divide both sides by 10,000 because we want to isolate the n. We can do some regular algebra to isolate n first. Okay, 1.5 equals 1.048 n. Now we can do a log. So we do log of 1.5 is equal to natural log of 1.048 n, which is equal to n natural log of 1.048 is equal to natural log of 1.5. N is equal to natural log of 1.5 divided by natural log of 1.048. Okay, and so you could divide that on the calculator to get the answer. 7. The mass of a radioactive substance remaining after 2 years is given by m equals 1,000 times e to the negative 0.04 t grams. Find the time taken for the mass to have reached 25 grams or reach 1% of its original value. So you do this using logs. The first thing that they're asking is, hey, what if there's 500 left? So it's 500 equals 1,000 times e to the negative 0.04 t. So we're going to isolate the t. First thing we're going to do is divide both sides by 1,000. And that gives us 0.5 equals e to the negative 0.04 t. Take the natural log of both sides. That gives us natural log of 0.5 equals, and natural log and e cancel each other out, negative 0.04 t. Divide both sides by negative 0.04. That gives us t equals natural log of 0.5 divided by negative 0.04. So you can divide that on your calculator and find out what the exact answer is. What about to reach 25 grams? So then you would just put 25 in there, equals 1,000, e to the negative 0.04 t. Again, divide both sides by 1,000. That would give you 0.025 equals e to the negative 0.04 t. Take the natural log of both sides. So t is going to be equal to natural log of 0.025 divided by negative 0.04. So you could put that in your calculator and find that. How about to reach 1% of its original value? 1% of its original value would be 1% of 1,000 is 10. So you'd have 10 equals 1,000 e to the negative 0.04 t. Divide both sides by 1,000. And you got 0.01 makes sense, 1%, is equal to e to the negative 0.04 t. Natural log of both sides, you get natural log of 0.01 equals negative 0.04 t. Remember, natural log and e undo each other. Divide both sides by negative 0.04. And then you end up with t equals natural log of 0.01 divided by negative 0.04. Okay? All right, 11. The weight of the radioactive substance remaining after 2 years is given by this equation. Sketch the graph of W against T. Write a function for T in terms of W. Hence, write the time required for the weight to reach 20 grams or 0.001 grams. Now, to find these points for the graph, you're definitely going to need the calculator. Okay, so you're going to start, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll put 1,000 here because that's the initial value, right? If t is 0, It'll give you w equals 1,000. What about at t equals 1? What would you have then? And now you're going to have to use a calculator to do that. If you got the calculator anyway, you might as well put the equation into y equals, and then you just get all the values instead of just one. Instead of like typing multiple times the same equation in. That would be silly. 2 to the negative 0.04t, which in this case is just x. And then we'll do the table. And so we see that it starts at 100. That was correct. 2, 3, 4, 5, 6, 7, 8, 9, 10. So at t equals 5, the value is 870. It's about there. Oops. It's about there. I'm sorry. It's about there. And then what about when t equals 10? What is it equal to then? 757. 757. Oops, it would be out there. Okay. So at 5 it was 870. 10 is going to be about 757. Okay, so that's the sketch. Write a function for t in terms of w. Now what they're asking for here is they want us to use logs to make an equation where it just says t equals something. And the way to do that, you have to use logs. So the first thing we're going to do is we're going to try to isolate t. The first thing we're going to do is we're going to divide both sides by 1,000. Then we're going to take the log of both sides. It could be log base 10, it could be natural log. Do natural log here. Okay, now, natural log of 2 to the negative 0.04t. Remember, you can take the exponent down because of one of the log rules. And here you have the natural log of w divided by 1,000. Okay. So t is equal to natural log of w divided by 1,000 divided by natural log of 2 divided by negative 0.04. Okay. So you can put that in your calculator and calculate what you would get, well, once you have a value for w. And so how do you find the value of t for 20 grams? You would just plug w equals 20 in there, and that will give you the value for t. Or you put the value 0.001 gram in there for w, and then you get another value for t. So that's how you would calculate part C. Number 13, last problem. The current, that's electric current, I, flowing in the transistor radio t seconds after it is switched off, is given by this. Show that it takes 50 divided by log 2 seconds for the current to drop to 10% of its original value. Okay, so the original value is I0. The new value is I. So 10% of its original value would be 10% times I0, which is just equal to 0.1 times I0. So that is equal to I0 times 2 to the negative 0.02t. So I divide both sides by I0. I want to isolate the t, of course, to figure out what the time is to get to 10%. Now 0.1 is equal to 2 to the negative 0.02t. And then I'm going to take the natural log of both sides. No, actually I'm going to take the log of both sides because it says the answer has log in it. Log base 10. So I'll have log of 0.1, and on the other side I have negative 0.02t log of 2. And then I'm going to divide both sides by log of 2. And then I have negative 0.02t is equal to log of 0.1 divided by log of 2. Then I'm going to divide both sides by negative 0.02. And then I'll get t equals the log of 0.1 divided by log of 2 divided by negative 0.02. Now somehow we need to manipulate this so that we end up getting 50 divided by log of 2. That might be kind of hard to see at first, but we can see that we do have log 2 there, so we're kind of close. Can we take the rest of this, log of 0.1, and divide it by negative 0.02 and figure out how we can get this? So let's do that. Let's group the things that aren't blue together. So let's see. If we wanted to write this, rewrite this, we could write it as this, log of 2, and this would be negative 0.02, because we're dividing by negative 0.02. Now, can we write, let's see, if we're dividing by negative 0.02, that's the same thing as multiplying by the inverse of negative 0.02, which is 50. Okay, so log of 0.1, log of 2, and then we could be multiplying by negative 50. So dividing by negative 0.02 is the same thing as multiplying by negative 50. And the log of 0.1 is actually negative 1, right? So then if you multiply negative 1 times negative 50, you get positive 50. And then on the bottom, you get log 2. So that's how it happens.